Music, photographs, documents, what used to take up shelf space in our home and office, can now be stored on the tiny memory card or flash drive. You can save your file on it, take them out of the device and transport them anywhere, as well as delete data you no longer need. A memory card fits into a slot in your digital device. A flash drive plugs into a USB port, the key component of both formats. A memory chip produced in factory that's 1000 times cleaner than a hospital operating room. It all begins with a wafer, a thin disk of pure silicon, a non-metallic natural element, which conduct electricity. An automated container system moves the wafer through more than 800 operations. At each stop, the wafer receives one of several layers of non-conductive material such as a silicon dioxide and conductive material such as a copper. A machine coats the layer with light-sensitive fluid, then apply UV light through a glass stencil of compact pattern of electrical circuitry. The exposed areas of fluid chemical react, blocking the material directly underneath into the circuitry pattern. Chemical baths then remove surrounding fluid and material, leaving only the layer of circuitry electrical pathway 2000 times narrower than a human hair. A robot tests a circuitry for every memory chip on the wafer. A single wafer measuring 30 cm in diameter yields hundreds of memory chips. The goal is to make those of chips as small as possible. In this industry, it's all about maximum memory in minimal space. That's why the operation thin the chip by grinding away 2/3 of silicon from the backside of the wafer. And one last step before cutting the wafer into individual memory chips. The machine applies tape to hold the separate chips together. A computer-guided saw slices the chip apart. Cutting silicon is like cutting glass. It requires a diamond-edged blade. In the next step, a robotic arm, following the wafer generating area, picks up the chip with pass testing and attracts each one of the fiberglass lead frame. The term lead refers to the frames pin which connect the chip to the digital device. Another robot wires the chip to the lead frame with gold thread that's about the width of the human hair. Gold is very conductive, so now the pathway is complete. Electricity will travel from the chip circuitry through the gold thread to the pin to the device. After a machine seals the chip in plastic, workers gently snap them apart and insert them in memory card housings. This plastic and metal housing is for memory card format known as compact flash. A small automated press locks the two halves of the housing together. The next station labels the front of the housing. Every single memory card undergoes testing for both function and speed. A laser machine etches product information into the back of housings. These are another format called Secure Digital or SD. They are assembled and labeled just like the compact flash cards. When the finished memory cards come off assembly line, workers conduct a final visual inspection. On flash drive assembly line, much the same process. A robot puts 20 lead frames on 20 circuit boards. Then the worker positions 20 USB connectors with a soldering machine bound to the boards. The final step, electronic testing to make sure the USB connection is working and wire the circuit board talking to the chip. The flash drives are now ready to go individual housings. This model has two-part plastic housing with pivot in and out of plastic case that can conveniently be attached to keychain or layered for easy portability. Flash drive or memory card storing in your digital effects is just a click away.